Today we'll be doing class 8 physics, and this time I've decided to do numericals on the board so that you people can understand it more clearly, okay? And I'll be doing numericals from your chapter 5, that is chapter 4, that is your work, energy and power. So I'll be doing some numericals related to it. So what I want you people to do is, as we do numericals today, please make sure that you have your books on your table or in front of you, so that when I am reading the questions, you people can refer to the book. Okay? Because as I read over here, you might not be able to understand the questions, and I'm not going to write it on the board because that's very time consuming. So I'll be reading the questions from the text, and you please refer it from your book. Okay? So numericals, that is page number 78. C, sub-question number 1. A force of 13 Newton acts on a body and moves it through a distance of 5 meters in the direction of force. Calculate the work done by the force. Okay, so number 1, what is given? In number 1, force is given. How much force does act on the body? 30 Newton. And when that force acts on that body, how much distance that the body displaced? The body displaced by 5 meters. You have to calculate the work done. So what's the formula for work done? Force into distance. Okay, the formula for the work done is force into distance. So how much is your force given? 13 Newton. And how much is the distance given? 5 meters. And you simply have to multiply 30 and 5. So when you multiply 30 and 5, you get it as 150 joule, which is the SI unit of work and energy. So this is how we calculate the work done when force is given and distance is given. You don't have to do anything, you simply have to multiply force and distance. Number 2. Okay, number 2. A man lifts a mass of 20 kg to a height of 2.5 meter. Assuming that the force of gravity on 1 kg mass is 10 Newton, find the work done by the man. Now here in question number 2, force is not given. Okay, we have to calculate the force before we calculate the work done. But what is given rather? Mass. Okay, so mass is given. How much is your mass given? Mass is given 20 kg. And distance is given. Your height here is your distance. How much is your distance given? 2.5 meter. What else is given? Force of gravity. Force of gravity on mass 1 kg is given. So what is your force of gravity on 1 kg? Force of gravity on 1 kg is your 10 Newton. Okay, this is for 1 kg. How much is the mass actually given in the question? 20 kg. So we have to find the force which acts on 20 kg. Okay, force of gravity on 20 kg. Will it be more or less? Obviously it will be more, because 1 kg is much lesser compared to 20 kg. So 20 kg being more than 1 kg, you have to multiply 20 into 10, which is equivalent to 200 Newton. So we got the force. What is your force now? Force is your 200 Newton. So what is the formula for work done? Force into distance. And what is the force on 20 kg? 200 Newton. What is the distance covered? 2.5 meter, which is equivalent to When you multiply them, you get it as 500 joule. Okay, so this is your work done. If force is not given directly and if mass is given, so we first calculate the force, then we calculate the work done. Okay, so this is the two different ways to calculate work done. One, when if force is given, you simply have to multiply force and distance. Second case, if force is not given, if mass is given, then you need to use this relationship. Okay? So we've done number 1 and number 2. Now you might just refer to it for a while. Okay, next number 3 and number 2 are exactly similar. So number 3 you can do it on your own. So I would want you to do it as your homework, as your assignment. Okay, number 3. Number 4 was done last time on the shown it on the PPT. So number 5. So I'll be doing number 5. Number 5. The question says, find the gravitational potential energy of 2.5 kg mass kept at a height of 15 meter above the ground. The force of gravity on mass 1 kg is 10 Newton. Okay, in number 5, we have to calculate potential energy. Okay, gravitational potential energy or just potential energy. So that will be mgh, that is mass into g into h. Mass is given. What is your mass given here? Mass is given as 2.5 kg. Your g is given as 10 Newton. Okay, we here says force of gravity. Force of gravity means your g, small g. So that is acceleration due to gravity, which is equal to 10 Newton. And what is your height given? Your height is given as 15 meter. Okay, your height is given as 15 meter. So what is the formula for potential energy? It's m into g into h. What is your m? M is your 2.5 kg. What is your g? 10. And what is your h? 15. So when you multiply them, you get it as 375.0 joule. Okay, you simply have to multiply. Mass is given, g is given, h is given. You simply have to multiply the values. So this is how we calculate potential energy. I hope it's clear. Number 5, mass is given, g is given, h is given. So in order to calculate potential energy, what do you have to do? You have to multiply mass into g into h. And the value that you get is your potential energy. Okay, then we will be doing, you don't need to do number 6 and 7. And we did kinetic energy also last time, how to calculate kinetic energy, and also how to compare the kinetic energy of two substances. So, what we do over here is, I'll be doing number 11. Okay, number 11 says, a pump raises water by spending 4 into 10 to the power 5 joule of energy in 10 seconds. Find the power of pump. Okay, so we have to calculate the power here. Question says, how much energy has been used? What's the formula for pump power? The formula for power is work divided by time. So how much work has been done over here? The work done here is 4 into 10 to the power 5 joule. Okay, 4 into 10 to the power 5 joule, which means 4 followed by how many zeros? 5, which is 4 lakh joule. And time given here is 10 seconds. we have to calculate the power. So what's the formula for power? Work done divided by time taken. So how much is your work done? Your work done is 4 lakh joule divided by how much time? 10 seconds. So joule second. So you cancel 0 and 0. So what are you left with? 40,000. And what is the units of power? It's watt. Okay, so it's given in the book, it's given 4 into 10 to the power 4. Why? Because there are how many zeros? 4 zeros. So it's written 10 to the power 4. You can write this way also, your answer will be correct. So this is how we calculate power. Work is done, work done is given, time is given. You simply have to divide them, do the cancellation if possible or not, do the division, and then you get the answer. So this is how we calculate the power. Now I'll be doing number 12. I hope it's clear till now. Number 12 says, it takes 20 seconds for girl A to climb up the stairs, while girl B takes 15 seconds to do the same job. Compare the work done, and number 2, the power spent by them. Okay, number 12, we have to calculate 2 different powers. There are 2 different girls, girl A and girl B. Okay, now how much time does girl A take to climb certain stairs? 20 seconds. And to climb the same steps, how much time does girl B takes? She takes 15 seconds. So let's assume, say there are 10 steps. Okay, 10 steps. So if girl A has to climb those 10 steps, she takes 20 seconds. And if the same steps, if girl B has to climb, that is 10 steps, if she has to climb 10 steps, then she takes 15 seconds. So the work done in both the cases are same. Only the time consumed by the girls are different. That is, the time taken by the girls to do the same work are different. So how much time does girl A take? 20 seconds. And how much time the girl B take to climb? She takes 15 seconds. The work done remains the same. So work done is the same because the same amount of work has been done by girl A and girl B. Therefore, if we are comparing the work done by girl A and girl B, then if we are comparing, we are finding the ratios. Okay? Every time there is comparison, it means we are finding the ratios. So that will be, let's assume the work done to be W and W. So they cancel each other, so what we left with? So they cancel each other, what are we left with? 1:1. That means work done by girl A and the work done by the girl B are same. That's why we take the ratio as 1:1. Now, number 2, power of girl A will be different because time taken is different. So as we know, power depends upon time. So work done, you can write it as W. Time taken is 20 seconds. Okay. Now power of girl B is, the work done is same W, but time taken is 15 seconds. So if we are comparing them, if we are comparing them, which means we are finding their ratios. So what will be the ratio? For A is to B. That is, your girl A, the power of girl A is the power of girl B, which means W by 22nd is to W by 15th. So the first remains as it is. Now you know very well, you have done ratio and proportion before also. So this ratio becomes into, and this second number becomes reciprocal, which means 15 divided by W. So they cancel each other. 5 3s are 15, 5 4s are 20. So what will be the ratio? The ratio will be 3:4. That means power of girl A is 3 and the power of girl B will be 4. So what do we conclude from here? We conclude that power of girl B is more than power of girl A, because she takes lesser time to do the same amount of work. Okay? So if there is any further clarification that you need regarding these numericals or any other questions from the text, please do feel free to give me a call or text me. And if you have any doubt, I would love to help you. Though there were some people who have been trying to reach to me, they do text me regarding some questions, and I do appreciate that. And I would appreciate if more and more would ask questions. And with this we complete the chapter 4, that is work, power and energy. And then you don't have to do any of the objectives in your copy. I only want you to do the question and answers in your copies. Okay, only the question answers, that is from page number 77, short long answer questions. Okay, and numericals are done on the board. So these are the numericals which are important, and also the numericals which were done in the earlier classes. So with this we conclude the chapter. Thank you.